Hey guys! It's Emily and Amanda here, and we're going to prove that the opening scene of Kingsman: The Secret Service cannot be done in real life. The scene involves a lady named Gazelle using her blade feet to split a man in two. Now, this seems impossible just because of the way that the movie is shot, however, we will prove it anyway. Here's the clip in its entirety. Gazelle comes up right behind the man, does some kind of spinning kick, and splits the man in two. Here you can see the two halves of his body hitting the ground. And that is the part that we'd like to disprove.
So we started by looking up the mass and the height of the actress that played Gazelle in Kingsman, and we found that she was 54 kilograms and 5 feet 5 inches. And originally we were going to use this to do a rotation kind of equation, but then we figured that we could probably disprove it by assuming that all of her mass was centered above the blade, just because that would make it a lot easier for her to slice through. And so if that disproves it, then we know that it would also not work in a more real life scenario. So then we looked up what the PSI is that it takes to break a human skull, and that is 15 pounds per square inch, which converts to about 103,421 newtons per meter squared. And then we looked up what it takes to fracture a vertebrae, and that one we couldn't find a pressure like pounds per square inch, so we just have a straight force. I think probably because the vertebrae is better at dispersing force throughout the entire system versus a skull, you kind of just put pressure on that one area. So we found that that was 300 or more newtons just to break the first few vertebrae in a human spine. Since we have the PSI for breaking a skull, we now need to find the surface area that is in contact. And so we found that the smallest blade humanly possible to make is 1 × 10⁻⁹ meters thick. And so then we used that as the width, and then we looked up how wide from front to back a human head usually is, and we found that to be about 9 inches or 22.86 centimeters. And so now we have our surface area, which we can multiply by the force, or by the pressure required to find the actual force on the skull. And then we can use the equation force equals mass times acceleration to figure out how much the foot slows down as it slices through the guy. And so based on the number of frames that you can see her foot and the blade in the shot, we can determine that it's going about no more than 16 meters per second. And so using these numbers, we can then multiply the width of the blade times the length of the skull and to get the surface area, and then multiplied that by the newtons per meter squared required to break a human skull. And then that gives us the force, and we set that equal to the mass times the acceleration. So the mass is 54 kilograms, so then we can just divide both sides by 54, and then we get that the acceleration is equal to 4.378 times 10⁻⁷ meters per second squared, which means that cutting through the top of the skull actually wouldn't slow her down much. So then we moved on to the vertebrae to test that. So this one's a little simpler because we don't have PSI, we just have a straight force. So we set that force, 3,000 newtons, equal to the mass times the acceleration. And so then we can just divide both sides by 54 and then get that the acceleration is equal to 66.67 meters per second just to get through the first vertebrae. And so that is now adds up to greater than the 16 meters per second that she started at. So it's going to slow her down to a stop by the time she just reaches the guy's neck. And that's considering that the entirety of her mass is centered above her blade, which is not true, because you would have to use a torque equation instead and consider like how she would rotate and how her foot would have like no tangential velocity and all of her momentum would be transferred to her center of mass basically. But instead of like dealing with that, since we can just disprove it with a simple force equals mass times acceleration equation, then we don't really need to go any farther, because there is no way that it could get any more ideal for this situation, for Giselle that is, than this.
So now we know that Giselle could not have split the man in two with her blade feet. It would be impossible because she would not have enough force to go through the man completely.